So now we will start up the line. We're running PVC, soft PVC compound. And as you can see, we've set the temperature controllers mainly at 160, the die at 150. And you can see we're allowing the material to run out of the die to begin with until we get nice pure compound. So now he just breaks that off, twists it so that he can feed it through the holes. So as you can see, it's not a difficult operation. But this is PVC and it's fairly thick walls, which makes it very, very easy to handle. It doesn't collapse. So you just slowly walk it down the water bath, slowly. You can see he's passing the tubing underneath these guide rollers to make sure that the tubing stays under the water. And right to the end of the water bath, we pull off the water and we can turn on the air to completely dry the tubing. Then the tubing goes through the laser scanner for diameter control. We can easily feed that through the front of the haul-off unit. Now he closed that down to grip. Now we're going to just let that run for a few minutes to let everything settle down before we pass through and start cutting the tubing. So we can close this and apply some air. This air is going down here, through here, and just pushing off any remaining water that's left on the tubing. And if you feel the tubing, it's perfectly dry. But this red light is on here because the size of the tubing is outside the tolerance. See, this is 4.22. The nominal, it should be 4.7. So it's above or it's below that diameter. So the alarm has come on. So we have to adjust the haul-off speed, extruder speed, and so on until this comes to 4.7 millimeters diameter, which is quite a large diameter for medical tubing. Now things are running quite smoothly. We want to bring up the whole water bath so that the unit here comes very close to the die. And you can see you can push this manually along the guide rails. We have a lock here, so that's unlocked, and we have stoppers so that we don't accidentally bump this into the die. So it gets to the stops, and then we can lock it, stop it moving back and forth. Depending on the material you're using, sometimes you would use vacuum, sometimes not. In fact, in this case, no need to use any vacuum. We're using PVC and it's quite thick wall, so it's very easy to control the outside diameter using this brass sleeve. But if we were using some other material, and particularly thin wall and stiff material, we would close this lid on the sizing box and lock it in position and apply whatever vacuum we want in here. So that sucks on through those slots and brings the motor tube in contact as it cools with the sleeve. And And furthermore, down here, this is a compressed air line. We can adjust the compressed air coming in here by that. We can get the reading on here. We just pull that out and adjust it to whatever we want. In fact, it's closed at the moment. We don't need to use this for PVC again, but the compressed air passes up here. So this is the inlet and this is the outlet. So this is the compressed air, passes down here, along here, around here, and it goes into the center of the die. And this is so that we can introduce some air so that the molten tubing doesn't collapse due to vacuum. So we put air inside to keep it blown up. So that's what this compressed air line is for. Now at the moment the tubing is a little bit too small. It's not 4.7 millimeters in diameter. So we want to increase the throughput a little bit of the extruder. So you can see it's running at the moment at 21.9 RPM. We can just use this to increase. In fact, we can, from past experience, we know that it should be around about 32 RPM. Now that should force more material and give a bigger diameter tubing. So after we've adjusted the screw speed, we can see that the diameter has gone up, but it's gone up too high now. It's around about 4.8. So see, the nominal should be 4.7, but the actual is about getting up to 4.9. So we have to go back to the extruder and reduce the speed of the screw a little until this comes down to 4.7. So let's go and do that. So we'll reduce that, let's say, make it 31 RPM. So the line is set down now, and we can see that the controller is measuring the outside diameter of the tubing, and it's within tolerance because the nominal, what we want, is 4.7 millimeters in diameter, and the tolerance plus or minus 0.05. So this is the actual. So it should be 4.7 plus 0.05, which is 4.75, and 4.7 minus 0.05, which is 4.65. So this is 4.65 running within the tolerances set. And no alarms coming on, so this is running within tolerance. So now we can start feeding the tubing onto the conveyor and chopping it according to the set lengths on the conveyor. So on this control panel here, we can set the length of the tubings to be cut. And for batch 1, the length has been set at 1,000 millimeters, in other words, 1 meter long. And when it gets to 50, then the flap will open, and a batch of 50 1 meter lengths will drop onto the table below. So we cut the tubing, feed it into this air jet unit, press it into there, feed it through the other jet blower and pull it. When it comes out onto the conveyor, then we can move this back again, stop here, lock it, and allow air here and here. So on this window on the control panel, it tells us that the first batch we're making lengths of 100 millimeters or 1 meter lengths, and we're making 10 for batch 1. And we've set here end batch pre-alarm, which means that we've set this at 2. When this when the number of lengths gets to 8, the alarm will sound to tell the operator that we're getting to the end of the batch. So that's what that 2 is. So when it gets to 8, the alarm will go, and then when it gets to 10 pieces, the flap below the conveyor will open and the parts will drop down. Okay, so that's the lengths and the quantities. We press the next button here. This is the cutting speed of the flywheel, 2,800 RPM, and the knife offset is 10 degrees. That just means the position of the knife. So that was for this button. The next button, this is controlling the blowing, which means the blow jets to blow the cut tubing off the conveyor down onto the holding bay. So there's a delay time from cutting to start of blowing, and this has been set at 4.2 seconds. The blowing duration, the time of blowing, in this case 0.6 seconds, and this 5 meters per minute is the conveyor speed. So we're ready to start cutting now. So now that we've set all the cutting conditions, we press cutter on and counter on. The cutter just cut, you can see down here. You can see there's a space between the cut tubing and the tubing that's following. You can hear the air blowing inside there. So when it cuts, now it's thrown that out and there's a space here. Now at the back of the conveyor, these posts, you can see there's a series of holes. There's one here, there's one here, there's one here, one here, here, all the way along here. And compressed air is provided inside here, so we get jets of air which will push the tubing, as you can see, when it gets to that 1 meter length. So it's coming along here, and you can actually feel it if you put your finger there. You can feel the air coming out. So we should get 10 of these before this flap opens, but after 8 we should get the alarm. So this has been set for batch 1 meter lengths to be cut, 10 lengths per batch, and this end of batch pre-alarm is 1, which means that when it gets to 9 cuts, the alarm will go off to tell the operator, the machine operator, that the batch is ready to be dropped from the holding bin down onto the table. So here we are. Oh, we have to begin the cutting, we press the counter, and that's cut. So we're doing the first cut. You can see it's dropped onto the conveyor. And this went to 1. So that's 1 of 10. And this next one will be 2 of 10. So when that gets to 9 of 10, the alarm will go off and the parts will drop down. 8 cuts out of 10. Now it's gone 9, the alarm has gone off. And when this cuts again, the parts will drop down onto this table. So here we see the ends of the cut tubing, which is very nice and square, not flattened or smeared or anything. Very nice cuts. So these are the batch of 10 we just made.